Okay folks, I am going to run through this question that we did in class, and I'm going to try and keep the video as short as possible just for ease of uploading it and for you watching it as well, because you'll be able to pause it in the middle of doing this, and if you're struggling with any of the sections, and rewind and look at them again. So hopefully it comes out fairly clear. So the question that we had earlier on was the reaction to extract iron from iron ore is represented in the following equation. We were told that 50.4 grams of the iron ore completely react with carbon monoxide. Now in the box, I've broken down what each of the different things in the balanced equation are. Now we see in the balanced equation as well that the ratio is in the big red numbers. So for every 1 mole of iron ore, I need 4 moles of carbon monoxide. And on the other side, that produces 3 moles of iron and 4 moles of carbon dioxide. That's the ratio that never changes. It's like if I was dividing out a cake, this person would get 1 square, this person would get 4, person would get 3, and this person would get 4 as well. That never changes no matter how big or small the cake is. That ratio never changes. It's the same in this chemical reaction. The ratio never changes even if the quantity that I have does. The only downside with this ratio is the only time I can use it is if the amount of the substance that I have is measured in moles, because remember, grams are not a fair way to compare amounts of substances because atoms weigh different amounts. So I need to compare them in something that is fair, and that's where moles come in. So I'm trying to solve 3 different things. I'm trying to find out the number of moles of iron ore used, which is this thing. I'm trying to find out how much iron would be formed. And I'm also trying to find out the number of molecules that will be formed at the end. So the only piece of information I'm given at the start is that I have 50.4 grams of iron ore. So to use my ratio and balanced equation, I need to convert this into moles. So the only formula that we've really learned that would be any use to me so far to answer part 1 would be the number of moles equals the mass in grams of whatever substance I'm looking at divided by that substance, or mm, which is the relative molecular mass. So for my iron ore, if I'm trying to work out the number of moles, I would need to work out how many grams there are. So I'm told that, so that's 50.4 grams. That's going to be divided by the RMM of my iron ore. You ignore the big number because remember, that's just telling me how many molecules are in the reaction or how many moles I need. All I'm worried about is how heavy 1 molecule is. So that's the little bit in black there. So how heavy is 1 iron ore molecule? Well, I need to add the parts together. So I need to add 3 irons, which are 5.85, and then I need to add 4 oxygens, which each weigh 16. And you add all of those together and it will work out to be 331.55. Now again, that side calculation is something that you can work out in your own time. Again, it's you have iron, you have 3 of them, which are 55.85 times 3, and oxygen is 16, and you have 4 of them, and you add those 2 together, and that gives you your RMM, which will work out as this. Okay, when you do that and put that into your calculator, the number of moles that you end up having is 0.21. So that means that at the beginning, I had 0.21 moles up here. That tells me a huge amount of information. From this, now I can work out how many moles of everything else I had. Because if I had 1 mole of this at the beginning, well then I'm going to have 4 times that of this. So that'd be 0.84. And if I had 1 mole of this at the beginning, I'm going to end up with 3 times that at the end. Okay, I didn't have 1 mole, I had this much, but I do know I'm going to have 3 times that over here. So that'll be 0.63. And I do know that if I had this much at the beginning, I'm going to have 4 times that at the end. So that'll be 0.84. So you'll have the same amount of this and this. So that allows me to kind of hopscotch and use and compare using that mole ratio, the big numbers in front of the molecules. So that tells me a huge amount of information now that I've figured out this. Okay, so have I answered part 1? The number of moles of iron oxide used, and the answer is yes. So that's part I solved. Part 2, I'm looking for the, just to read it here again, the mass of iron formed in the reaction. So I need to find iron, which is this thing. So I need to find how many grams of it I formed. Now, do I know? And the answer is no, but what I have solved is that I have 0.63 moles of it. So to solve part 2, I'm going to have to use the formula again. Number of moles equals the mass in grams divided by the RMM, but this time it's specifically for iron. So the number of moles will equal, to kind of scratch that, I do know the number of moles already, so that will be 0.63. That equals however many grams I have, which I don't know, so I'll just still let that represent mass in grams, over the RMM, this time of just iron. I ignored the big 3 because I'm just concerned about how heavy one molecule is, the RMM, relative molecular mass, how heavy one molecule is. So that would be 55.85. So I'm left with this here. A number equals a fraction. So to solve that, what I'll do is I'll put 0.63 over 1, and I'll let that equal to the mass in grams over the RMM, and I'll cross multiply. And when you cross multiply, your mass ends up equaling 35.18 grams. So that is how many grams of this I would have ended up with. Okay, so that was quite easy once I knew what I was looking for. Part 3, I'm now looking for the number of CO2 molecules in the reaction. So first of all, let's find CO2. There it is. So, do I know how many molecules I have? The answer is no. But what I do know is that I have that many moles because I worked it out from the ratio. So I have that many moles. Another thing I always know is that when I have 1 mole, I always have that many particles or molecules, whatever you want to call them. And that number, remember, is Avogadro's number. It's a constant, it never changes, and it's in your log tables if you forget it, and that never changes. Now what I want to figure out is how many molecules will be in 0.84 moles. And I have no idea how many particles or molecules that contains. Now what I have though is molecules equals particles and moles equals particles and moles equals particles. So when I have that, I can cross multiply. So x times 1 would be x, and that equals 0.84 times 6 by 10 to the 23. Put that into your calculator, and x works out as 5.04 by 10 to the power of 23 molecules of CO2. So that's how many molecules I have in this reaction. Now, once I backtrack here and I figured out that that's how many moles I have, I can easily see how many moles of everything else I have, and then from that I can work out how many grams of each I have, how many molecules of each I have. It's quite easy to kind of work on from there. So if any of that isn't making any sense, I'd advise you pause the video and you go slowly through the part that's not making sense and rewind if you need to. So hopefully that helps doing your homework tonight.